and reconnected. Well, let's see. So the network cut out, and the projector now is giving us issues. If this holds. So if you go the calculation, x minus 3 is linear. And x plus 4 is also linear. So these are the same. We can call that x minus c case. But you can have other cases like x minus c squared, or you can have x squared, something that is not factorable. So we are going to learn 4 cases and then use those 4 cases to set up the problem. When you grind through algebra, you will eventually break this into these separate problems here. Now, the key is to understand that if you have the integral for something like this, you can't integrate this. None of the methods we learned so far work. But if you look at this side, it is easy to use 2ln, right? 2u substitution to get 3ln x plus 4 and 2ln x minus 3. So there will be a trivial integration in comparison to what's on the right-hand side, which is the reason why we do all of this. So let's learn 4 cases to set up the problem. Case number 1. Yes, I wrote blah over x minus c. So we are going to have, it's only the denominator what matters, and your setup is a over x minus c. If you have, again, blah divided by x minus c squared, that's a repeated linear, your setup is going to be a over x minus c plus b over x minus c squared. Third case, if you have something divided by ax squared plus bx plus c, and it's very important for you to say that this cannot be factored any further. So you cannot factor this into linears. If you can, then it's this case, right? We have ax plus b divided by ax squared plus bx plus c. So clearly this is a lowercase and uppercase a's and b's, they're not the same. And then finally you have a repeated one for the quadratics. So ax squared plus bx plus c, oh no, square later, plus cx plus b over ax squared plus bx plus c squared. So those are the 4 setup situations. So on the 4 you have blah divided by ax squared plus bx plus c, everything squared. And it will give you what I wrote on the board. Ax plus b divided by ax squared plus bx plus c plus cx plus d divided by ax squared plus bx plus c everything squared. Yeah, there we go. This is what you're memorizing. On your exam, you will probably have two problems involving this. One, that it's kind of quick calculation to solve the full problem where you have to integrate. And the other one, that is just the setup, because you would probably need 3 hours to solve it. Because, take a look at this. If you have one of these, and a linear, let's say, how many variables do you have? 1, 2, 3, 4, 5. You would have 5 variables. 5 variables is 5 equations in a 5 by 5 system. To solve 5 by 5 system by hand, whew, because you break that into 4 by 4 systems, and then 4 by 4s you break into 3 by 3 systems, and then 3 by 3 systems are broken into 2 by 2 systems. To eliminate the variable, eliminate the variable. It takes so long to solve these things. So, as I said, something that it's vanilla for exam to calculate, and then one that will be terrible to calculate, but at least you know to set it up. Computers today solve all of these things easily, but if you can't set it up, you have nothing to put in a computer. So that's the extent of what you need to know to work. Also for differential equations, we tend to keep everything down to 2 or maximum 3 variables, right, for calculation. But solving a 4 by 4 system, I mean, it can take time. 5 is worse. So there's that. So now that we know this, we are finally ready to attack our problem over here and solve it through the decomposition. Remember, I'm not doing calculus yet. This is preliminary work for us to learn enough algebra so that we can do the decomposition. So what you see here is x minus 3 and x plus 4. Those are two linear terms, and since they are two linear terms, they would both fall under the rule 1. So I'm just going to put rule 1 and rule 1 underneath this, or case. Case 1, case 1. It's a case 1 because you have linear terms. Since it's a case 1 term, your job is to put a divided by x minus 3. Remember, it was a blah over the linear term, and you write what it is. Plus, you have another linear. Now, a is already used up, so now you can go with the capital B for x plus 4. And that's because a is used up. So you will just continue using the next letter in alphabet as you progress. I understand that in your setup over here, the first letter is always A, right? But let's say you have all of these cases. And if you have all of these cases going in this order, then this would be a B, this would be a C, this would be a D, this would be E, right, as you go down. So you always pick up the next letter. When you use a variable for something, capital A, then you don't get to use it again, which is the reason we are using two case 1s now. One gets A, the other one gets B. From this point on, we are supposed to solve this. All I need to do is to calculate value of capital A and capital B. I have an equation here, right? You see the equation, and all I need to do is to find the values for A and B. Now, we already know what those values are, 3 and 2, right? Here's your A, here's your B. We already know what those values are, but you know what? Let's calculate them. Let's see the method. So, the only thing that you can do here is to add these two fractions, and you know the way to do that, right? X plus 4 on top and bottom over here, and x minus 3 on top and bottom. Our left-hand side is still 5x minus 1 over x minus 3, x plus 4. And now our right-hand side has the same denominator, which is why we can just get rid of it. If you multiply both sides by this denominator, it just goes away. So we don't have to worry about that. But look at the top. You got ax plus 4a plus bx minus 3b. That's the top. Denominators cancel. Here, I'll write it in blood. Because it's the same denominator on left and right side. Just multiply both sides by x minus 3x plus 4. They both go away. So now you are left with the equation 5x minus 1 is equal to, and here is the million-dollar move. Bunch up your x's together and your non-variable terms, like 4a and 3b, push them together, and then just compare coefficients. So if I take a look at the two guys that have x's, that's going to be a plus b, everything times x. And then we have plus 4a minus 3b. So I bunch up all of the terms that have x and all of the terms that do not have x. And now it's a simple comparison, because the red 5 has to match this, and the blue negative 1 has to match that, because the left has to equal the right, x equals x, right? So whatever you see on the left has to equal what's on the right. And they have the same form. You see that this part is something times x. Here is your something times x. This is no x, that is no x. So they have to have exactly the same values in order for equal sign to hold between them. So that's where you get your two equations. The stuff that I underlined in red is the red equation, 5 equals a plus b. And the stuff that I outlined in blue is negative 1 is equal to 4a minus 3b. So from this point on, you just write this as a plus b equals 5, and 4a minus 3b equals negative 1. This is a system of two equations, two unknowns. You should be able to solve this, learn this in algebra. You know the substitution method, the guess and check method, the graphing method, the elimination method, right? You have all of these essential oils, right? Whatever works, I don't care. Just get a solution, because still, we are not in calculus. This is still algebra. Probably the fastest way would be to multiply top by 3. That will kill b's. So when I add 3a plus 4a is 7a, b's are gone, and then I have 3 times 5 is 15 minus 1 is 14, and woohoo, a is 2. If a is 2, a plus b is equal to 5. Well, a is 2, so b must be 3. Well, we got a 2 and 3, right? So now, you go carefully here. A is x minus 3, so 2 over x minus 3, plus b is 3 over x minus 4. Really sad way to lose the grade is when you calculate these guys correctly and then you put them in the wrong spots over here. You know what that does later on for calculus? Obviously messes up everything, because this is our first step of a problem, to calculate this a and b so that we can transform that big fraction into these two. Now kicks in calculus. So if you have integral of 5x minus 1 divided by x minus 3x plus 4 dx equals, I'll put these 3 dots here, and then put equals, integral open parenthesis, 2 minus x minus 3 plus 3 over x minus 4. Oh, I was actually, that was that x plus 3?
Minus 3 plus 4.
Oh, plus 4. Okay. Plus 4. There we go. Dx. Now, these 3 dots work above, right? That's what the 3 dots are. So if you, when you get, not if, but when you get your calculus problem and you recognize partial fraction decomposition, right? Partial fraction decomposition, which is the stuff we did up there first, and then you have this. Now, to solve this, you have your integral, you kick 2 outside, 1 over x minus 3 dx, plus kick 3 outside, 1 over x plus 4 dx. Use u sub if you are not already comfortable, but by doing the homework for this section, you will immediately see that when you get this, you know it's ln immediately. So 2 ln absolute x minus 3 plus 3 ln absolute x plus 4 plus c. And that would be the answer. So as you can see, integration, right, doesn't get to be really terrible, but the procedure for partial fraction decomposition makes up for it, right, in a big way. So guys, this is the entire section. This is the entire lecture. Now, all we have are example after example after example with different cases involved, which involve clearly more calculations, more variables, more equations, more systems, and all of that stuff, right? So it just becomes more annoying. If you were able to follow the process for this example and you understand it, well, you're done. Now, question is, can you shovel through algebra that is before us, right? So let's find more examples in the book and work. This is one of those cases where I can't put whatever, because if I put whatever, you're going to end up with a equals negative 117 divided by 82. You know what I mean? And then you have to shovel that through the rest of the problem. So the problems that they have in the book tend to be already worked out in a sense that you're getting some reasonable numbers. You know, maybe a quarter or 3/2, but most likely not 117 over 82, for A, and then you have to do everything else. There is one more thing that I need to mention now, and then when we run into a problem, I will repeat it and probably write it down in blood. And that is, this method only works when your numerator exponent is lower than the denominator exponent. So, x times x over here in denominator is x squared. The order of the polynomial in denominator is 2. The order over here is 1 on top, so that's smaller, so the method is going to work. If they have the same exponents, let's say this was 5x squared minus 1. Well, you have to do long division first to peel off those extra exponents. Because the method only works when the exponent on the top is smaller than the bottom. If they're equal, or if this is bigger. Long division first to peel off all of the extra exponents that we can't use, and then it kicks in. Look at your formulas. X to the 1, no x. X to the 1, no x. X squared, single x. You see that? It's always smaller by 1. It's a pattern. It has to always be smaller than 1. It goes higher than that, but we don't deal with that in calculus courses. So these are the only 4 courses out of infinitely many 4 cases out of infinitely many that you learned here. So make sure that when you see a problem, you quickly in your head, just look at how many x's you have. 1, 2, I got 2, I got 1, perfect, method works. Right, so denominator has to have higher exponent. Denominator can have a 4th exponent, numerator could have a 1, that's okay. As long as denominator is bigger. They can't be the same, can't be smaller. Denominator has to have a bigger exponent than the numerator. Let's take a look at example in the book. So they dump, great. They do not separate anything. They just dump everything in a pile, the problems, and it's technically good luck. All right, fine. We can deal. Hopefully. $35. Let's see how fast I regret any of these that I pick. 35 is x squared plus 12x minus 4 divided by x cubed minus 4x dx. Step number 1 of your life. Can I avoid this terrible technique by u substitution? Right? What is the derivative of the denominator, and is it up here? Well, the derivative is 3x squared minus 4. No, it's not up there. So tough luck. Can't you use sub? So we are stuck with partial fraction decomposition. Okay, fine. I need to factor this because factors will tell me which cases I get to use. I get to kick x, get x squared minus 4, and then I realize that factors further into x minus 2, x plus 2. Woohoo! I have 3 linear factors. There is here x minus c. Well, c is 0, but that's okay. And then x minus 2 and x plus 2, they're all linear factors. So, my partial fraction decomposition, x squared plus 12x minus 4 divided by x minus 2, x plus 2, is going to be a over x plus b over x minus 2 plus c over x plus 2. So I'll case 1, case 1, case 1, all linear, and they don't repeat. Remember, case 2 is a repeated linear. If you are to have x plus 2 everything squared, then that's a repeated linear. But these are all single linears. So this is still in, yes, we are shoveling the cheapest possible problems. Great. So we have our setup. The next is to add all of the fractions on the right so that we can compare and eventually calculate ABC. Now, when I teach this in algebra, I say to my students, let's play the game of what's missing for each one of these terms, because you are supposed to add them. When you are multiplying the first one, you need to multiply x squared minus 4 to top and bottom, because that will bring the denominator to be x minus 2, x plus 2. When you go to the next one, you have x plus 2, right? That's what's missing. x plus 2 to get to the common denominator of x minus 2, x plus 2. And finally, the last one, x minus 2. So all of these are our variables. We know that the denominator is going to go away because it's going to be the same on both sides. So we can just ignore it. We have x squared plus 12x minus 4 equals 2. And now you have to multiply all of this. So you have ax to the fourth, no, ax squared minus 4a. Plus bx squared plus 2bx. You see this x multiplies the 2, gives you 2x, and then times b, so 2bx. Plus cx squared minus 2cx. Get your x squares together so you can compare it to x squared. Then get your single x's together to compare it with a single x. And then get all of those that have no x's together to compare to negative 4. So the next line is going to be this term, and this term all have x squared. So that's a plus b plus c x squared. Are we all bueno on that? Good. Then this term and this term are all with a single x. So that's going to be 2b minus 2c times single x. And finally, you just have negative 4a at the end. Time to bring your colors. Coefficient of x squared is 1, and that's all of this. Next one is, let's say, blue, in front of x. And the next one, let's go orange. Constant, constant, no x's. So your job is to pile up all x squares, pile up all x's, and pile up all without x's. And then you just compare the left and the right. If these two are to be equal, they have to have the same coefficients. So now, my red equation is 1 equals a plus b plus c. My blue equation, 12 equals 2b, or not 2b, I mean minus 2c. And negative 4 is equal to negative 4a. Aren't we all happy to see the orange equation? This is when I say, if a three variable system shows up on a test, it better be this one, right? Where one of the equation is going to immediately give you one of the variables, and you do not have to spend additional 3 hours chasing the system, which is algebra, not calculus, right? So this one over here immediately tells us that a is 1. And then you plug in. So when you plug in a is equal to 1, you get 1 plus b plus c equals to 1, which is b plus, I'm going to keep it written the same. 1 equals 1 plus b plus c. And the second equation with the 12 doesn't have any a's, so you just copy it. And as you can see, the system now reverted down to a 2 by 2 system because you already have your a. So the top equation is b plus c equals to 0 when you subtract 1. And the bottom equation is 2b minus 2c is equal to 12. The fast way to solve this one is to multiply top by 2, which gives you 4b is equal to 12, from where b is equal to 3. And now I need the value for c. Well, if b is 3 and b plus c is 0, then c must be what? Good, negative 3. So c must be negative 3. Excellent. Now I can go back to my integral all the way up there and replace all of this with our partial fraction decomposition. So the integral x squared plus 12x minus 4 divided by x cubed minus 4x dx is going to be the integral of, and now a is 1 over x plus b is 3 divided by, what was it, x minus 2. And finally, the c is negative 3, so it's a negative here. Negative 3 of x plus 2, everything dx. You have 3 ln integrals. Again, if you are used to this form, you don't have to go through u sub horror. You will immediately see that you have 1 over x minus 2, 1 over x plus 2, and each one of those is just ln of the denominator. And the values you have on top are going as the coefficients of ln's. So that's the fast way to integrate this. So the first one is ln of absolute x plus 3 times ln of absolute x minus 2 minus 3 ln of absolute x plus 2, and then plus c. So yes, the problem is over, but then you still can simplify. If you pull the 3 in front of those two ln's, you realize that you have ln and ln, and they can actually combine into a single ln with those formulas that either compress or expand logs. So what you can do, now this is mathematical gymnastics. You factor 3, and then you're left with ln of x minus 2 minus ln of x plus 2 plus c. And when you have a subtraction of two logs, their arguments divide. So we have ln of absolute x plus 3 times of the single ln of x minus 2 over x plus 2 plus c. You can go further. You can bring these 3 as the exponent, and then you have a single ln and a single ln. So there is even more that you can do. All of these are, valid answer that you can leave. If you're a computer science major, you have to keep reducing this all the way till you can't reduce it anymore, because you want the least amount of operations in your code, the fastest possible program, right? So this is further equal to ln absolute x plus ln of x minus 2 over x plus 2, everything cubed, plus c. And now you can push all of this into a single ln, because now when you have addition, this x multiplies everything. So you have x times x minus 2 x plus 2 cubed plus c. In general, most of the people abandon ship right here. Over here, you have the boss level. All right? because this has less calculations than this one. So if you're a computer science major, you should make yourself a goal of doing this, because then you're good. Break time? When we come back, we'll have time for 2 more examples, and that's it. Time flies when you're having fun. We're here 2 hours already. So we'll be back with the part 2.